minus 3x. Here we find minus 6, right?
Yeah, I got to
And
that step.
So we both write it.
Mm-hmm. Yeah. It's the same.
Yeah.
I guess it's just two different.
Yeah.
That's confusing. So,
do you remember how to find 0?
All right, guys. Let's take a look at these. I know fractions are poor little fractions, man.
Thank you.
thank you.
They're so hated. And they're the ones that are all in parts, man. So yeah, this one especially. I got mixed numbers going on. I got division of fractions going on. So what the hell? How do I do this? So if I just had the division of fractions, let's kind of break this thing down. If instead of all that crap, it was just something like 7/8 divided by what do you got? 4/3 or something. How do you do that? No. So
Flip and multiply?
let me ask you this: what's x plus x? 2x. You're on like. It's a trick question. What's x plus y? X plus y. I love it. They're not like terms. When you add or subtract, you have to have like terms. So if I had 2/5 plus 3/5, that's 5/5. They're both something fifths. So all like denominators is a type of like terms. That's it. Do I need like terms when I multiply? What's x plus x squared? Oh shit. What's x plus x squared? Are they like terms?
No.
No. Good. There. She's safe. Right. X plus x squared. They're not like terms. You with me? Well, x squared plus x squared would be
2x squared.
2x squared. I love it. Stop there for a second. I like it. I like it. So, what's x times x squared?
X cubed.
X cubed. Were you able to do it even though they're not like terms?
Yeah.
Yes, good. I like it. So addition, subtraction needs exactly like terms. Multiplication, division? No, not so much. They're not nearly as stringent. Are you guys with me? So the same thing applies to these. Because what are variables? Numbers I don't know yet. So how do numbers act? The same damn way, really. Right? So I don't need LCD here. I'm not adding or subtracting. They don't have to be like terms. In fact, the whole idea with division and multiplication is reducing with fractions, right? And making like terms is the opposite of reducing. It's building things up. So, what else can I do here?
Multiply, unclip them.
Yeah, no cross multiply. I'll tell you this. Unless you're really careful, there's a lot of places you could use something related to cross multiplication. There's only one place that you can directly use cross multiplication. You have a fraction equals a fraction. That's it. Because it's just a shortcut. Here, you could not officially use cross multiply. You could do something related to it. But if you're not careful, you'll get the wrong number on top and the wrong number on the bottom. Ooh, so it's a shortcut. If you're not comfortable with it, screw it. All right, so let's try again. How else can I? What do I have to do?
Do you simplify the 4 and the 8?
No, I can't. I like it because in order for things to reduce or cancel, right, I have to have opposite operations. The 4 and the 8 are opposite sides. They're dividing already. The division in the middle, does it cancel division? Of course not. Division does not cancel division. If there was a times in the middle, then I could reduce the 4 and the 8 because they're opposite operations. Mm-hmm. That's another huge place people make mistakes. Make sure if you're crossing something out that they're actually opposite operations happening. Hopefully that kind of makes sense. If they're opposite operations, they should cancel somehow. I like it. So no, I can't because the operations are not opposite. Shit. So what the hell do I do? All right, well, let me show you why you do what you do. Some of you guys might remember you're just sitting there because you're like, come on, it's too late. You multiply by the reciprocal, right? And then you can see nothing cancels, right? That would be 21 over. All right. Okay. Now, do you guys, does that sound familiar? You guys remember that? I like it. I like it. Just momentarily, it was blocked somewhere in the back of your brain. Did anybody ever show you why the hell you do that? Anybody ever tell you why you do that? You just kind of went like, sure, whatever. You should never, especially with me, you don't just accept what I know what the hell I'm talking about, but my job is to explain to you why things work the way they do. So don't just go, well, he said it like this. He said it was like that. No, you go, that doesn't make any sense. What do you mean? Anything raised with 0 power is 1. What the hell is that shit? Well, I'll show you in a minute. But this, let me see if you guys are with me on this. This is something you don't see very often, but it's important to see it. 7/8 divided by 4/3. I could write it like this, although I don't blame you that you don't. Can you write it like this? Of course you could. Now what's bad about that? That's like fracception, right? There's a fraction inside of a fraction, right? That sucks so bad. Fracception. Oh, you like that? All right, thank you. I made that up myself. Yay. Not just now. I can't do it. Now watch this. How do I make the bottom not a fraction anymore? What do I multiply the bottom by to make it become 1? So it's not a fraction anymore. It's just 1. Yeah, I love it. You guys with me? You multiply it by the reciprocal, and it will become 1. Are you guys cool with that? Because the stuff will cancel. But if you do something to the bottom, you better. So if I multiply this by 3/4, so that dies and becomes 1. Now it's not fracception. The bottom's a freaking 1. But what do I have to do to the top? Do the same thing. So what am I saying? That equals that. That's why the rule is true, right? A little more important than knowing a rule is knowing why it's true. Because then your brain goes, oh, there is actually a reason things work the way they do. Not just some dude going, this is the way we said it will work. No, there's a reason it works. Okay, I like it. So let's go back to the actual problem. Right? You guys are like, that's good for that problem. What about the one we had? So that once I have a single fraction here, I know what to do now. I'm going to multiply by 20 over 33. I like it. So if you just do that, I'm going to multiply by 20 over 33 eventually. What do I do with all this weird shit inside? How do I do that difference?
You got to get it a common denominator.
All right, I like it. You need a common denominator.
But then you can also
A common denominator. Common denominator. It's a fine line between the numerator and denominator. So yeah, so it'll become 3 and... So you get a common denominator. What's the common denominator going to be? 10. Obviously, because 5 can become 10. It ain't 50. That is a common, but not the lowest common denominator. So I can make this become 3 and... What tenths? 2. 2 tenths. So it's got to multiply top and bottom by 2.
You would ever multiply the number to the side?
Definitely not. Because it's not part of the fraction. You guys see what I'm saying?
Yeah.
So, real quick little example. When you're doing like 4.1 minus 3.17, don't you have to add a 0 at the end? Do you have to do anything to the 4 that was there? No. You're just messing with the decimal part to make it kind of match. That's what we're doing. We're messing with a fractional part to make it match the other fractional part. Now what's wrong? What's sort of wrong with that?
You need to put the 3 and the 2 into the numerator.
Yeah. I can't really do 2 tenths minus 9 tenths. You could borrow, and that gets really freaky weird. But I'd rather do what I'm going to have to do eventually anyway. I'd rather write those mixed numbers as improper fractions. I like it. So how do I make this into an improper fraction? 10 times 3 plus 2. 32. And of course this is 10 times 2 plus 9. 29. Real quick word on that. Why does that work the way it does? Well, 3 and 2 tenths. This is one of the worst decisions in history to write this like this. We know this doesn't mean 3 times 2 tenths, because that would be 6 tenths, which is less than 1. This is 3 and 2 tenths. So what does this really mean? What operation should be in the middle there that we just don't write? What's the and? Plus. So just go with me. I know the shortcut is 10 times 3 is 30 plus 2 is 32. Because I love it when I'm showing students why something works, and then somebody goes, I'm not going to do it that way. No, of course you're not going to do it this way. I'm showing you why it works, the shortcut. Please do the shortcut. But you got to see why the hell it works. So this is really 3 plus 2 tenths. And of course I can't add them because currently what's under the 3? A 1. In fact, what's going to always be under the whole number out front It's a freaking 1. So what's it always going to need to be multiplied by?
Denominator.
What's underneath the fraction, dude? Always. You guys start to see why the shortcut works?
Yeah.
Maybe. Some of you guys are like, you lost me at welcome to math. So I'm going to multiply by 10. I'm going to multiply by whatever the shit that is, right? So that's this part of the shortcut. 10 times 3 is 30. That's that part of the shortcut, because now what I'm going to get, I'm going to get 30 over 10 plus 2 over 10. And now you see the other part. 10 times 3 is 30 plus 2. Because that's what I would do if I did it the long way, right? Okay. A log it. Now, what's 32 tenths minus 29 tenths? 3 tenths. 11. Times 20 over 33. Come on, 3. And of course, what's the smart way to do this? I could do 60 over 330. That's not the smart way to do this.
Simplify.
Yeah, I can simplify before I multiply, right? I can make the numbers smaller before I make them stupid big. So 3 and 33, don't they reduce down?
1 and 11.
Yeah, that goes 1 and 11. 10 and 20, that goes 1 and 2. So 1 times 2 is 2. 1 times 11 is 11. 2 over 11. Yes, ma'am.
Can you move it up? You multiplied it by 2, and I came kind of late. I'm not sure why you did that.
Multiply what by 2, sorry? Oh, here?
Yes.
Oh. Well, somebody noticed that that's 3 and 1/5 minus 2 and 9/10, so they said, let's make an LCD first. Now, you didn't have to do that. You could have done 5 times 3 is 15 plus 1 is 16 fifths. But then you would have had minus 29 tenths. You would have still had to make an LCD.
Okay.
So it doesn't matter when you do it, you would have to do it eventually. Just somebody mentioned it first, so that's what I did first.
Okay.
Do you guys see what I'm saying? So you could have made it 16 over 5, but then you would have had to multiply by 2 then, which is 32 over 10. Same thing we got. So there are certain things that have to be done. Very often, it doesn't matter what order you do them in, but we know all too well that it does matter sometimes. Sort of like good old PEMDAS. Please excuse my dumbass son. Or dear Aunt Sally, whichever way you like better. Yeah. And speak of the devil, there, you know. So PEMDAS is never gone. It's always there. It's the grammar of math. So grammar never goes away. Right? If you don't get the grammar right, people are going to be, what the hell just happened? What are you talking about? This problem is loaded with shit, but what are the very last things? What's PEMDAS mean? So one thing I hate is I never write it like this, except when I'm showing you I'm not going to write it like that. Please excuse my dumbass son or dear Aunt Sally. It could have been this. Which one of those is easier to say? First one. The second one makes you sound drunk. It pins, and you walk this line. I want you to understand, because really the better way to write it is like this. Definitely parentheses. Then exponents. Then either one of these as they come. And then finally either one of these as they come. Like. Otherwise you get something crazy like this if you don't do that. If I have $5 and I owe you 10.
Here is different.
Stay with me. If I have $5 and I owe you 10, right? Can I pay you off? Obviously, no. But what if I'm walking down the street and I see a $10 bill? Can I pay you off then? Yes. Now, if you do this though, 5 minus 20.
And here is like
Who do I owe $15 to? That's shit, right? I don't want you to balance my checkbook. So what I got to do is I got to do it as it comes. 5 minus 10 is.
-5.
That's the $5 I would owe you if I gave you that $5. I still owe you 5. But then I found a $10 bill, so now I can pay you off and still have $5 left, right? The brave armies and get the 5 for 5, or not. All right, maybe. So this guy. What are the last things I'm going to do in this problem?
Subtract the 2 at the end.
Yeah, the minus 2 at the end. And at the beginning,
The 3 minus.
3 minus. Because 3 minus, I don't know yet, minus 2. That's the correct way to look at this. So the 3 minus and minus 2 are just going to kind of come on the outside, just waiting and waiting and waiting. It's like, come on, middle dude, what the hell are you? Maybe. So I don't want to see no negative 2 in the front. That doesn't make any sense because it's not 3 minus 5. It's 3 minus 5 times. I don't know yet. So what do I do first in here? So the 3 minus, the minus 2 come for the ride. What can I do first in here?
You cube everything in the parentheses? Or
Yeah.
solve the parentheses first?
Parentheses first, right? So, please, dear God, the only time you have to FOIL is when the inside you can't be done. So if I had x plus 2 squared, then you have to write it twice and FOIL it, right? Because you don't know. What's x plus 2? I don't freaking know. But what's negative 1 minus 2?
Negative 3.
So why FOIL shit? The only reason FOIL exists is it's a workaround when I can't do the inside first. But I can do the inside first. Dear God, do it. So this is 3 minus 5 times negative 3 cubed divided by 9 times 3. Now, here's the part that really screws people up. What's the only thing I'm dividing by?
Right.
9. If you put 9 times 3 is 27, you're all of a sudden dividing by 27. You just all agreed that we're only dividing by 9. It's not fair to then make it divided by 20. What the hell? Where did that come from? So if I put 9 on the bottom, the 3 wouldn't go with it. That doesn't make any sense. It's divided by 9 times 3. Why would it come down here? That doesn't make any sense. But that's where there are actually teachers that teach that multiplication is before division because they're dumb. They should stop teaching. Stop. Right? So it isn't that way. And that's pretty much exactly why it isn't that way. So we're going to get to that point first. Don't put 27 there. You got to stop yourself. Say, brain, stop it. What can I do next? What's the thing I got to do next?
Cube the negative 3.
Yeah, cube. I got to do exponents now, right? So what is negative 3 cubed?
Negative 27.
Negative 27. I like it. I love the people that are like, why do you keep rewriting everything? I don't want to do that. Well, I'd rather rewrite everything and get it right than save time to get it wrong. Right? I want to make mistakes fast. No. Now, I'm on the multiplication division level. That's the next thing I would do. So the whole middle chunk is that. So I'm going to just do that as it comes. Right? What's negative 5 times negative 27?
135.
135. Now there are ways to get around this. I'm going to do by the textbook right now, but you can. The more comfortable you get, the more you can kind of rearrange things a little bit. What's 135 divided by 9?
15.
15. You guys see, I'm just working on this middle chunk. 5 and down is there. That divided by 9 is there. 15 times 3?
45.
45. 3 and 45 is 48 minus 2?
46.
46. So some people believe that PEMDAS lives in a section, and when you're past that section, well, we're past that section. No, it's the underlying grammar matter. You got to do it that way, or else we wouldn't agree. And then math doesn't mean shit. I know some of you guys believe that anyway, right? But that's not true. Okay, any questions on that one? All right, here's what I was talking about a minute ago. You can't do what's inside. So you gotta do what? I love the fact that we still call this FOIL, even though there's not a first, outer, inner, last. So the kind of math teacher I am, I wish we never taught you FOIL, because it's unnecessary. It's bullshit. It actually makes it seem harder than it is. Oh, we got to teach you a little word because it's so hard. No. What do I do with the 2x? I distribute it. What else needs to be distributed?
The plus 3.
The 3. I don't need FOIL. I just distribute. Everybody gets a chance to distribute. That's all it is. It's just repeated distribution. That's all it is. I don't need FOIL bullshit. The minute I put more letters in there, what is it now? I need an M for middle or something. I don't know what word that would be. So the 2x gets a term. 2x times 4x squared.
8x cubed.
8x cubed. 2x times negative 6x.
Minus 12x squared.
Minus 12x squared. 2x times 9.
Plus 18x.
Plus 18x. And then the 3 gets a term. Are you guys with me? 3 gets a turn. 3 times 4x squared.
12x squared
12x squared. 3 times negative 6x.
minus 18x.
And you don't have to do it the way I'm doing it. I'm doing it the way I'm doing it for 2 reasons. One, I'm going to run out of room, but secondly, just to kind of line my like terms up as they go. And then what's 3 times 9?
27.
27, great. So these
Cancel.
cancel, cancel. Some of you guys noticed this is the sum of cubes, and this is how it would factor. So you can see all the cancellations that happen. So we'll talk about cubes obviously in a minute. All right. How's that? Is that decent? Okay.
You wouldn't simplify it.
Say again?
You wouldn't like simplify it.
Oh, okay. All right. Now watch this. You ready? Simplify is the opposite of factor. So simplify means do the operations. Factor means undo multiplication.
That's what I meant.
I like it. So no, you wouldn't. Because the instructions here was
Simplify.
simplify. I love it. So you would never factor in a section that's asked you to simplify. I like it. Simplify is a word that means carry out all the operations. Factor means undo multiplication. They're opposite instructions. Does that make sense? I like it. So if I said multiply 4 times 9, and you tell me, well, it's 2 times 2 times 3 times 3. Well, yeah. But you got to put it together. Okay. This one, some of you guys really, really love this one. Let me give myself some more room to talk about this one. And you're all like, do whatever the hell you want to.
Oh, no.
You may be right, but I don't like
Cooperate. Cooperate. Okay.
half in here and half lost.
All right. So exponents are really kind of misunderstood sometimes. Poor little dudes. Okay. Real quick. Obviously, if you multiply like bases, what do you do with the powers? Add them. Why? Because here there's a couple x's, and then I'm multiplying 3 more x's, so of course I've got 5 freaking x's. Right? Don't make it a big deal. There's no 6 if there's no, in fact, let me say this. This is going to freak some of you guys out. In this problem, there is no 2 or 3. There isn't. There's no 2. There's no 3. This is just how many x's and how many x's. So nowhere does it say 2 times 3. It says, got a couple x's times 3 more x's is 5 x's in a row.
That's fine.
I like it. Cool. Okay, that's old news. So obviously it should make sense that when I divide,
Then
what would I do?
is
Subtract, because here there's, why did I do 7? There's 7 x's over 4 x's. How many x's cancel? 4 of them. How many are left? Where? On the top. I like it. This would be x cubed over 1, which we don't write. So the shortcut is 7 minus 4 is 3. But again, it's more important, it's kind of more important to know why a shortcut works than to just know the shortcut. Okay. So now let's investigate what 0 power means. That's going to come up in a problem, the next problem. If I had x to the 4th on the bottom, what would I put on there so it becomes x to the 0 using the property we just discovered?
X to the 4th?
Another x to the 4th, right? Because 4 minus 4 is 0. It's amazing. Well, what is something divided by itself? 1. 1. All right, done. Thank you. Right? That's it. That's it. Now, another reason why x to the 0 is 1. Another way to look at it is, what's the only number I multiply by that keeps something the same? 1. It's the multiplicative identity. When you multiply by it, it maintains the thing's identity. So what is x to the 0 times x to the 7th? Well, you add powers, so it becomes... So I multiplied this by something that kept it the same. This must be 1. There's another reason, another way to look at it. Maybe. Anything to the 0 power is 1, except 0. 0 to the 0 power, you don't have to worry about that unless you take calculus. So I'm not going to throw that at you. You with me? We're assuming this is not 0. You guys? Okay, I won't say anything else about that. You're all like, well, what is that then, Jeff? Well, that's something else. It's not even undefined. It's called indeterminate. It's a whole nother level. Okay, so let's leave that guy alone. All right, maybe. So what about a negative power? So let me ask you again. By the way, real quick, I know I'm not the best writer in the world. Today's kind of review, so I'm not being the most organized right now. I'm just throwing some problems up to review. When we get into new shit, I'll be a little more organized. What would I put on the top so it becomes this? What would have to be true about what's on the top?
3.
3. I like it. 3, yeah. But if we do it like we did this one, because I'm going to simplify this just a different way, then the answer's got to be the same. Whatever way I choose to do something, the answer's got to be the same. So I got 3 x's on top, 4 on the bottom. How many cancel?
3.
3.
How many are left?
1.
Where?
On the bottom.
All right, so negative power means flip. So if you think about it, when I divide like bases, I subtract. So negative power is the same thing as something on the bottom, dividing, because it's going to subtract away. That's the one that obviously applies to that problem we're looking at right now. What are the only things in there that are going to flip then?
The A and the B.
Yeah, that 6 A's on the top, right? They don't like where they are. That's another way to look at it. They're all negative. They don't want to be there. So they want to be on the bottom. So what I'm going to do, what's the last thing you have to worry about in this problem? Thank God.
Negative 2 squared.
Negative 2 on the very outside, right? Because I don't know what the inside is yet. I don't even know what to do to that power yet. Don't worry about them yet. So real quick, help me out. 24 over 40. I don't care what other shit I put with that. I can do the same thing to it always, which is, yeah, and you divide both by 8, so it becomes 3 over 5. Always look for that part of the problem, the easy part of the problem, right? Those 6 A's, what do they want to do?
Go to the bottom.
They want to go down. Let me see if I can do this with less writing. How many A's are already down there?
7.
7.
How many A's are coming?
6.
So now I'm going to have a total of how many on the bottom?
13.
Okay. Right. Now, the rule still applies. You could do negative 6 minus 7. Because when you divide, you subtract. And what's negative 6 minus 7? Negative 13. And then you would flip those 13 A's and finally catch up to what we just did. And a lot of people make mistakes with negatives. So I'd much rather just rewrite it with no negatives. That's awesome. You wish you could always do that, right? Negatives are one of the places we make the most mistakes. So sure enough, I could rewrite it, bring these 6 A's down. There's 7 there already, so there's 13. Same thing with the B's. Those want to go up. There's already 7 up there, so now there's
14.
14. Even if you forgot all this, does this at least feel familiar? I don't know. Some of you guys, it might have been a while. Some of you guys just took stuff last semester. You should feel a little bit bad. But the rest of you guys, if it's been years and years, let it come back. What's the outer power telling us to do? 2 things.
Square and then flip.
Square it
And flip it.
and flip it. So I'm going to flip. And what's being flipped? What's it on? What's that exponent on?
The entire fraction.
The whole thing. So I'm going to flip the whole thing. And then I still have to square it. There. That's the correct way to look at that. That outer power says 2 things. It says flip it. We go, okay, flipped. And squared. Okay. So I'm going to flip it. And I still have to square it. So if I square everything, what do I get? 5 squared is 25. A13 squared, uh-oh. Is there a 13 in there? No. I have 2 groups of 13 A's. So how many A's do I have? 26. I love it. So when you raise something with a power to a power, you multiply powers. Because it's the definition of multiplication. If I had 2 crates, and there's 13 apples in each, how many apples do I got? 2 times 13, right? Yes? So I have 2 groups of 13 A's, so of course I got 26 A's. A 26. On the bottom, I'm going to get 9. B to the 28. Oh, snap. Now, real quick word about everything I'm doing. The way I'm showing you is not the only way to do this problem, right? As long as you show me what you're doing, I can kind of follow it. There's multiple ways. There's different orders to do this in. There's multiple procedures to use. You could bring the negative 2 in first, although that's the silliest thing to me. Some teachers teach that, but it doesn't make much sense. I'd rather simplify the inside and then do that thing. But as long as you show me what you're doing, I can follow your logic, you're fine. This is not the only way I'll accept it. This is the way that I kind of do it. This is the way that makes the most sense to me. So that's the way I'm going to show you. Any questions on that one?
Yeah.
Yeah.
Can you explain like a little bit more how the exponents went from -6/7 to 14, 13?
Okay. You ready? Let me explain it sort of the same way I explained this weirdness here, believe it or not. So let's just focus on the A's. The A's were like this, weren't they? Right? So now watch. How would I make the top become 1? Let me see if anybody can do this. What do I raise something to make it 1? I raise something to the 0 power. What would I multiply the top by to make it a to the 0? To multiply by a to the... All right, I left you hanging a little bit. All right, I'm sorry. A to the -6 times a to the what is a to the 0? What do I add to -6 to make it become 0? 6. So if I multiply the top by a to the 6th, it becomes a to the 0, which is 1. You guys with me? Now, if I multiply the top by a to the 6, I better
Bottom.
bottom by a to the 6. That's where the a to the 13th. So the shortcut is just take these and move them down. So it really, really is a shortcut. The rule itself is a shortcut. Negative powers mean flip. That's a shortcut. So I don't have to do all this freaky work. So anything to a negative power, if it's up top, it wants to be down. If it gets down there, it's happy, it's positive. If it's on the bottom, it wants to go up. How you guys doing? Okay. Some of you guys I don't want to play poker with. There we are. I have no emotion. Okay. You move that. Sure. I'll give myself some more room. All right. Is that cool? Mm-hmm. All right. What about this guy? This is where people make some good mistakes. What are the two things being raised to a 0 power? 3 is being raised to a 0 power, so that becomes 1. What else? -2 to the 0's power, so that becomes 1. Right? And then I just rewrite. So I got this thing, which is 1, minus 2 times this thing, which is 1. So I replaced the stuff being raised to a 0 power, I replaced it with 1 because that's what the freak they are. And now, how do I do that? 1 minus 2 is done. Yeah. A lot of people make this 1 minus 1, but is this 2 being raised to a 0 power? No. It's not in the parentheses. It's not being affected by that 0 power. I like it. I like it. It's the same thing as this evilness. This evilness here. No? Yes? No? These are not the same answer. This is 2 squared with a negative in front of it. There's only one negative. This one, there's 2 2's and 2 negatives. So on the top one, the negatives cancel. Because there's freaking 2 of them, right? They kill each other. The bottom one is only 1 negative, it doesn't die. So the top one is 4. Because it's this. And the bottom one is just a negative sitting in front of 2 2's, so it's -4. Yeah, I like it. So the power can only go so far. Parentheses help it get to more things. If there are no parentheses, there's no help for it. It can only get on the thing it's on right on. It can only get to that one thing. Maybe. All right. Well, some of you guys have this weirdest looking one. Please help. All right. That should have come up sometime before. All right. What about this guy? Some people give up on this just because there's x's in there. But what's beautiful about these two fractions? They already have the same denominator. So I can just add the tops then, right? What's 3x plus 2 minus x?
2x plus 2.
Now, if you stop there, you're wrong. You got to be careful.
You can do 2 times x plus 1.
I like it. You can factor the top, so you can see if it has any parts that cancel the bottom. I like it. You can't do this. You can't cross the x's out and make it 4 over 2 or something. Right? Why can't I do that? Why can't I just freaking, if I have this, 2x plus 2 over x plus 1, why can't I just cancel the x's?
Because 2x is different
What's
from x
division
plus
the opposite of?
1. Multiply.
And this is involved in an addition problem, right?
Yeah.
Division can't break into an addition problem and do so. I can't do it. What's being divided by x? Nothing. Nothing in here is being divided by x. There's something being divided by x plus 1. I like it, maybe. Can you reduce 8 over 5?
No.
No, even though 5 is 4 plus 1, who gives a shit? I can't rewrite the bottom in terms of addition to help me. I have to rewrite the bottom in terms of multiplication. Then I could kill a part of it. And that would be factoring it, right? So the same thing I've got to do here. Well, how do I factor that? It's good old GCF. Out comes a 2. And I'm left with x plus 1. Now I see that. Make it 2. So no matter what you make x, this will always come out to be 2. I didn't. Maybe. What about this guy here? This should be bread and butter, right? I mean, math 88, math 90, something that's constant through the whole thing. I told my 88 students, one of the most important things you get from this class, solving equations. It's the bread and butter, right? So solving this should be easy by now. Okay, so how do I do this? What do I do first, of course?
Foil.
Oh, distribute. I like it. Now here's where people make a mistake. Negative 3 times x, negative 3x, negative 3 times negative 4,
It's 12.
plus 12. So that negative is part of the 3. It's gonna, the whole thing is going to go through. Like it? How are we doing so far? Okay. Equals, and then the other side is really only one thing I could do.
2x plus 4.
Yeah, 2x plus 4. Now what can I do on this side here? I can do,
Cancel for 2x.
Yeah.
1x.
yeah,
Or negative 1x.
negative x, and then negative 2 plus 12,
10.
plus 10.
Three x equals 6.
Oh, yeah, okay. So now you almost always get to this point where you have x's and numbers, x's and numbers. You pick a side. X is on one side, numbers on the other. And if I have control over it, I'm going to make sure that it doesn't come out negative, because that's the place that always screws me up. Stupid negative. So instead of subtracting 2x, I'm going to add x. Do you have to? No. You'll get the same answer if you do it right, but I'm not going to let negatives show up if I don't have to. I'm freaking good at math. I have no problem saying that, because that's like one of my only skills is math. So, but even me, I'm not going to let negatives show up if I don't have to. Because I'm a human. I'm going to make more mistakes if I do that. So add x, 10 equals 3x plus 4, and then I subtract 4, get the numbers on the other side, and then finally I can divide by 3, x equals good old 2. And like always, you can plug it back in and check it if you have time.
I got it off.
I like it. What about, any questions on that one?
No.
What about this one?
No, this is also.
Now watch this. I want to get the idea. I don't like fractions, but I can't always do this. But since this is an equation, I'm allowed to do the same thing to both sides. So how do I kill fractions if I multiply? I can kill fractions, right?
Mm-hmm.
And here I'm allowed to multiply because I have two sides. If I'm simplifying, I can't kill fractions. I can't. But if I'm solving an equation, I can kill them. If I multiply by 3, do all the fractions die?
No.
No. If I multiply by 6,
No.
2 of them die, but not the big old 12. So here's the way I tell people to do this, because it's going to help us to when the bottoms are variable expressions. We're going to do it the same way we're about to do it. Make all the bottoms the same. So obviously the LCD is 12. So what do I do to this to make it 12 on the bottom?
Multiply by 4.
Multiply by 4. This guy,
2.
2. So I get 8x over 12 minus 10 over 12 equals x plus 7 over 12.
Mm-hmm.
And then,
Everything's being divided by 12.
yeah.
So what do I do to both sides?
Multiply by 12.
Multiply by 12. All the freaking 12s cancel. You guys see that?
Mm-hmm.
If everything's being divided by 12 and I multiply both sides, I'm allowed to multiply both sides by 38 if I wanted to. I'm allowed to multiply both sides by the square root of 27. Would I do those weird things? No.
No.
But I'm going to multiply by something that helps me. I'm going to multiply by 12 because that's going to make all those stupid 12s disappear. So if I multiply this side by 12, I got to multiply this side by 12. So all the 12s cancel. That kicks so much ass. And now this should be easy. Right, just subtract x, add 10, I get 7x equals 17, I get 17 over 7.
Yeah.
Bam. With fractions, unless I say otherwise, I'd rather have the answer as a reduced fraction than some decimal. Any decimal you give me is going to be wrong because you're going to have to stop somewhere. You don't want to write the whole answer out because that would never stop. Holy shit. So 17 over 7 is the answer. Okay, you guys doing all right? So those two problems, they both have the exact same idea. Undo what's being done. That problem had a lot of division going on. So what's one of the first things we did? We multiplied to undo what's being done to my poor little x dudes, right? So you try to get x by itself. This problem is different. Because this one, I can get all my x's together. All my x terms are together. That's awesome. Can I do the same thing here?
No.
No. What's x squared minus 3x? X squared minus 3x. I can't combine those. I can't get all my x's together, so I have to have a different way to do this problem. So many guys do quadratic formula for everything in the universe. My God. It'll work. But can you factor this thing?
Yeah.
Yeah. Right? How do you factor this? And why the hell would I factor this thing? I don't know. Let's do it first and we'll talk about why. How do I factor this? Be x for x squared.
Yeah.
It's good. 6 and 3 make 18. If I make the 6 negative and the 3 positive, comes out negative 3 in the middle. Hopefully that factoring is understood. One of the first things you want to make sure, hopefully everybody's able to solve equations. If you're not, holy shit, start there. If you forgot your factoring, that's the next thing. Factoring is huge. It's huge. So, what do I do now? Why did I do this? Because now I have some number times some number is 0. What do I know has to be true?
Numbers is 0.
The only way I can multiply two numbers and make them 0 is if one of them is 0. So the only number that works on this side to do this process is 0. What if there was this times that equals 4? Well, it could be 4 and 1, 2 and 2, 8 and 1/2, 36 and 1/9. There's an infinite number of ways to make 4. If this is 0, one of them's got to be 0, then I can get an exact answer, right? It's called the zero product property or whatever the hell the book you're looking at calls it. So this will be x minus 6 is 0, or x plus 3 is 0. So what do you get here? X is 6, or x is negative 3. And this is actually called the fundamental theorem of algebra. The fact that the highest power in that problem was the second power, and how many answers did we get? 2. So if it was a third power, I can expect 3 answers. There might be repeats, like I could get 2 3 times. Or there might be a real one and 2 complex ones. Holy shit. You guys talk about complex numbers yet? Some of you guys know about complex numbers? Some of you guys don't? Okay, we'll talk about them. All right. They sound exciting. Here's the factor section. So this, I just want to show you guys something real quick. On my website, I've got a little factoring review handout. So I've got up at the top of the handout is a little quick reference guide. And then below that is each of those kind of blown up with examples and explanations as to why they work. So you can go there and print that out for yourself if you want to. No, you can't use this on a test. But it's good to have sitting next to you for homework so you kind of remember all this stuff.
Okay, fine.
There's the copy of the first homework assignment, and there is a calculator procedures page and 2 pages that we'll go over when we get to graphing. Okay, so back to this. Okay, this one was easy. This one was easy. Why? Because the first number was a
Square.
1. Right? Isn't there a 1 here?
Yeah.
Yeah.
All right, so when there's a 1 in front of that, if it factors, it will be relatively easy. All I got to do is find the two numbers that work. Because the first things have to be x and x. Here, it's frickin' 16. It could be 4x and 4x, 8x and 2x, 16x and 1x, or the other way around for each of those. Shit. So I don't know if you guys use the insane little x dude. I don't know why that helps people, but it seems to help people. So what the hell? It's not anything magic about it. You do the exact same work. Anybody remember the first step I've got to do here?
Great.
16 times negative 3. So don't find factors of negative 3 that make 8. There aren't any anyway. I have to take the 16 into account. So 16 times negative 3 is 48. Negative 48. And then I find factors of negative 48 that make 8. I like the cricket, do you know?
4.
12 and 4, I like it. Which one's got to be negative? 4. The smaller one to make the middle come out to be positive. I like it. Now the next mistake people make, can somebody tell me a real quick explanation as to why this can't possibly be the answer? Because x times x is not 16x squared, so it can't be the answer. Okay, now some of you guys might, if you do this, if you use a process where you divide each of those numbers by something and reduce it and bullshit, no, I'm not going to let that happen. Unless you can explain to me exactly why it works. I haven't had a single person meet me on that challenge. Right? Some of you guys don't know what I'm talking about. It's great. Some people call it the bottoms-up method or something like that. Yeah, whatever. And, which is dumb. The hard part is done. The rest of this is easy, so why should there be a shortcut for the rest of this? I don't know. Who knows what to do with those two numbers now? Not that. That's wrong. What do I do with those two numbers?
X plus 12.
Separate them.
Good. Take the middle term, separate it, because 8x is 12x minus 4x, right? And if I have a choice, I'm going to put the negative one first. Just because, again, if there's a minus in the middle, it kind of is a place I could make a mistake. And now, how many terms do I... What, Jeff? I love you, Jeff. You're an awesome person. There you go. Now, that's kind of awesome. I heard a few of you about to say something. What did I just do to make sure that... Because you guys don't even realize when I write something, I'm really quickly scanning it to make sure it makes sense. So I was like, negative 4 plus 8. Wait a second. So I wrote something, and then I made sure it goes back to where I was just coming from. And it didn't. I'm like, shit. So that's supposed to be a 12 there. But now, how many terms do I have? 4. And what can I do then? Grouping. I love it. And grouping is relatively easy. Comes out of these two. Good. 4x. What would be left? 4x minus 1. I like it. Good. So plus 3. So I get a 4x minus 1 again.
4x minus 1.
I like it. Or the other way around, of course, yes. When you multiply things, it doesn't matter what order they're in. 8 times 6 is 6 times 8. So you could have that in the other order if you wanted to, yes.
What happened to 8x?
8x is negative 4x plus 12x.
Okay.
So if I said, what's 12x minus 4x? You would say 8x. Those two things are the same. So I really want to make sense. Those three terms suck. That's hard. That's not easy to do. So the idea behind this process is make them 4 terms and then try to group them. The only way the grouping will work is by doing that process up there, the negative 48. Those two numbers will make the grouping work. So I can make the middle term plus 2x plus 6x. I can make it plus 5x plus 3x. None of that's going to make the grouping work. If I find the numbers the way we did, it's going to guarantee that it's working. That's why this process, when I was taught this, it was called the surefire method. Surefire. I'm a Georgia boy, so. Surefire is going to work. If that's factorable, it's going to work. I like it. All right. Is that cool? Yeah.
Just really quickly, I see how when you got the 4 terms and then you grouped them, but going to 4x plus 3 and 4x minus 1, can you just explain that real quick?
Oh.
Can you just do the minus 1
Yeah,
and the...
and where is 4x?
You ready?
I just want to see where
How do
that
you
4x
factor
goes.
this?
4x. You would take a b out?
Take a b out. Whatever this is, it's in both of them, so I can take it out. So how would I factor this then? 4x times 4x minus 1, or was it plus 1? Minus 3 times 4x plus 1.
No, it was 4x plus 3.
Oh, well, it doesn't really matter. How would I factor this? This is the same in both, so it can come out, and then I would be left with 4x,
4x minus 3. So
minus 3, yeah.
Oh, okay.
Of course, I got the plus and the minus mixed up, but I don't care.
I see how that
That's why it works that way.
Just
It's
pull
really
that
just the GCF. I like it. Is it cool?
Okay. Yeah.
Still didn't
Because 4x minus 1 is a number.
So you just get it down to the same combination where
Yes.
you can...
So how do you know you're on the right track with grouping? This is the same as that.
Right. And
If they
that's-
aren't, you can't do shit.
And that's how you know.
I love the people that still do something. But if that's not the same as this, then you made a mistake, or it's not factorable. Like sometimes people take a negative out and they forget to change the sign or something.
Okay.
So the problem is actually telling you, hey, wait, you made a mistake.
Okay.
I wish every problem did that, but no.
Isn't the 4x minus 1 in square?
Definitely not.
So it'd be-
Are you cool with the fact? I want this. This is kind of nifty.
No.
This is what there aren't two b's here. There's one b that was distributed. There aren't two 4x minus 1s. There's one 4x minus 1 that was distributed. So it's not 4x minus 1 squared. Do you see that? There aren't two 4x minus 1s. There's one of them that would then be distributed to both of those things. Maybe. Maybe not. Okay. All right. All right. What about this guy here?
Factor of x. Or,
Yeah, is it a cubes?
yeah.
Yes.
How do I know it isn't?
The
It's
4x
49 something cubed.
X,
It is, but is it something nice cubed? No, it's something squared, right? And how about that x on the other dude? Is it something cubed?
yeah.
No, right? So what's going to save your ass so many times is people just kind of jump into a method when they don't even try GCF. GCF is always what you try first. Because either it's the only thing you can do, or it makes what's left over easier to do. So what comes out of both, of course?
X.
X. And of course, this would be x squared minus 49. And now this I can see is difference of squares, which you call a thank God problem. Or thank whatever favorite deity you have, right? Because all I have to do with this